As always, it's good to have you here at Math Rocks with Mr. Cox. In the previous video, I showed you how to take a system of equations like this and use the idea of substitution to substitute the value of y into this equation. And for this to happen, you had to have at least one of the equations solved for either y or x. In this case, the answer would be 3, 2, which means these two lines meet at the point 3, 2. So then the question comes up, well, what if you had a different system like the one here in blue? Well, neither one is solved for y or x, so how would you solve this kind of system? If you want to find out how that works, stick around. Let's get it on! So this other method is called the elimination method, and how it works is a little bit different from substitution because, as you see, neither of these two equations is either solved for y or x. But what you can do is we're going to end up eliminating one of the variables, and basically what you want to do is you want to add these together, and then hopefully one of the variables will go away. So I'm going to go ahead and add these together. 2x plus 3x is 5x. Plus y minus y is no y's, and that's good, we want that to happen. And then 10 plus 5 is 15. And from here, all you have to do is divide by 5. So therefore, x equals 3. And then what we can do is pick either equation. It should work for both. I'm going to pick the top equation over here. So I know that x is 3. So I can therefore say 2 times x value of 3 plus y equals 10. Well, 2 times 3 is 6, so 6 plus y equals 10, and if we subtract 6 from both sides, we get y equals 4, which means 3, 4 would be the intersection of these two lines. And you can also check it in the other equation here. If we plugged in a 3 here and if we plugged in a 4 here, 3 times 3 is 9, and 9 minus 4 is 5. So it'll work in both equations. And ideally, you're going to get these two equations right off the bat, one of the variables going away or being eliminated when you add them together. Well, what happens when you try to do the same process here, and I'm going to go ahead and do that right now. 2x and 3x is 5x, but then when I add the y's together, I get negative y. So one of the variables did not go away. So obviously that's a problem. We want one variable to be eliminated. So here's the trick. What you can do is you can go ahead and you can multiply the equations by a number, and I'll show you how that works now. So I notice I have a positive 1y and a negative 2y. And it would be awesome if this y wasn't a y and instead it was a 2y. So I'm going to go ahead and I'm going to multiply the entire equation by 2. So 2 times 2x is 4x. 2 times y is 2y. And then obviously 2 times 16, grab your calculator, that's 32. I'm going to rewrite this other second equation right below it here. So I get 3x minus 2y equals 17. Now, when I go ahead and I add my equations together, I'm going to get 7x, I'm going to get no y's equals 49. Divide by 7, I get x equals 7. And then what I want to do is pick one of the original equations. I'm going to go ahead and I'm going to pick the top one here. So if I take 2 times my x value of 7, add on y, it should equal 16. 2 times 7 is 14. And if we have 14 plus y equals 16, then y has to be 2, which means our intersection is at the point 7, 2. And once again, I can plug in these values in the other equations. If I put a 7 here and a 2 here, 3 times 7 is 21, 2 times 2 is 4, and 21 minus 4 is 17. So it should check. So this is a valid way to solve this by multiplying one of the equations by a number so that one of your variables gets eliminated. If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show. So the final thing that might happen is where you have a situation where when you add these together, you would get 7x plus 5y. So once again, we can't just add our equations together right away. And if you notice, we can't just multiply 3, for instance, by a number to get 4, or this 3 by a number to get 2. So we're going to end up multiplying both equations by a number. And I'm going to try to eliminate the y's, and you can try to eliminate either x's or y's, it doesn't really matter. But you'll notice that 2 and 3, well, what's the first number that 2 and 3 both go into is 6. So I'm going to turn one of them into a 6, one of them into a negative 6. So to make this into a positive 6, I'm going to need to multiply by 3. So when I multiply all of these terms here by 3, I'm going to get 12x, I'm going to get 6y, and then I'm going to get negative 6. When I do the same thing here, I'm not going to multiply this by 3, but I need to turn it into a negative 6. So I'm going to have to multiply by a negative 2. So negative 2 times 3x is negative 6x. Negative 2 times 3y is negative 6y. And then finally, negative 2 times 6 is negative 12. Now when I add the equations together, I get 6x equals negative 18. Therefore, x must be negative 3. So it's okay. You can multiply both equations by different numbers, and that works just fine. Now I want to figure out what y is. So I'm going to use the top equation. So 4 times x, so x is negative 3, plus 2y equals negative 2. 4 times negative 3 is negative 12, so I get negative 12 plus 2y equals negative 2. I'm going to add 12 to both sides. So if I add 12, I'm going to get 10 over here. So I get 2y equals 10. Therefore, y must equal 5. So where do these two lines intersect would be at the point negative 3, comma 5. So now you see the three different scenarios of how to eliminate a variable. You're going to sometimes just luck out and you can add the equations together, or sometimes you're going to have to multiply one of the equations or both of them by a number so that when you add the equations together, one of the variables gets eliminated. Hope you got a lot out of this video. Hope to see you again soon. Thanks for watching.